So greetings, YouTube. This is a beautiful mind here. So, one other thing. One sec. All right. So we are back. All right. Yeah, I had to change a setting or two. Let's see. Okay. So, welcome back, scholars. Let me see. Welcome back, scholars. So, this is going to be our lecture for applied statistics for week 4, Monday. A few announcements. So, I hope everyone had a rejuvenating, restful spring break. I hope everyone is doing well. Let's see. So we do have an exam this week. We have exam 2 this week. It'll be posted sometime during the week, definitely by Friday. It'll be due this Saturday at 11:59 p.m. I'm more than likely will post it before Friday, but it will be due this Saturday by 11:59 p.m. As with all assignments, we can actually work on all assignments past the due date, but with a late penalty. Typical assignments has a penalty of 20%, so the highest you can make is an 80. And then if you submit an exam late, the highest you can make is a 79, which is a high C. Okay. Aside from that, we're just gonna keep going with the material. It's mainly the exam this week, and also there is a participation and honesty quiz on Moodle, so be sure to get that submitted. And I'm available if you have questions or if you need support or help with anything. All right. Let me get my pen. All right. So with that, I think we're just going to go ahead and move into the material today. So today we just want to, so this week I just wanted to focus on chapter 4. The exam I think is over chapters 2 and 3. That sounds right. We'll see when we post it. But today what I want to do is focus on chapter 4. All right. So we're going to be moving into chapter 4, discrete probability distributions. So an outline for chapter 4, section 4.1 is on probability distributions. On Wednesday, I'd like to do section 4.2 on binomial distributions. And on Friday, I'd like to do section 4.3 on a few more discrete probability distributions. So moving into section 4.1 on probability distribution, the objectives here: how to distinguish between discrete random variables and continuous random variables, how to construct a discrete probability distribution and its graph, and how to determine if a distribution is a probability distribution, how to find the mean, variance, and standard deviation of a discrete probability distribution, and how to find the expected value of a discrete probability distribution. Okay, so a few terms. We have random variables. This represents a numerical value associated with each outcome of a probability distribution. We typically denote it by X, and some examples of random variables are X is going to be the number of sales calls a salesperson makes in one day, or X can be the number of hours spent on sales calls in a day. So with these examples really quickly. So if we look at the number of sales calls a salesperson makes in a day, what's the least, just really quickly to yourself, try to answer the following questions before I give the answer. What's the least number of sales call a person can make in a day? What's the next number of sales call a salesperson can make in a day? Can you make a number of sales calls between your first answer and your second answer? If it's no, then that should be an example of a discrete distribution. Discrete just means countable. Versus the second one says number of hours spent on a sales call in a day. What's the least number of hours that you could spend on a sales call in a day? What's the next number of hours that you could spend on sales calls in a day? Can you spend a number? Can you spend an amount of time between your first answer and your second answer? For instance, if your first answer was 0 hours and your second answer was 1 hour, Can you spend half an hour on a sales call? Can you spend a quarter of an hour on a sales call? So then, what's the true next number of hours you can spend on a sales call? There is no next number, right? Because there's infinitely many results there. So that's an example of a continuous random variable. So continuous just means uncountable, and discrete just means countable. So those are two examples on a discrete random variable versus a continuous random variable. Okay, so for this chapter, we're going to be focusing on discrete random variables. So a discrete random variable has a finite or countable number of possible outcomes that can be listed. For example, the number of sales calls a salesperson can make in a day. For again, if we were to ask ourselves what's the least number of sales calls a person can make in a day, would be 0. What's the next number of sales calls a salesperson can make in a day? They can make 1 call. Is it possible for the salesperson to make half a call? No, right? Because either they're calling or they are not. You can't do half a call, right? So this is a countable set, and it just keeps going, right? So then the outcomes in this is an example of a countable set. So this is an example of a discrete random variable. Versus a continuous random variable, if we consider the example where we had the hours spent on a sales call in a day, again, the least number of hours that a salesperson can spend on calls in a day, they can do 0 hours in a day. Then when I asked, your next answer may have been, well, the next number of hours they can do is 1 hour. Then I was like, okay, well, can you do some number in between? Can you do like half of an hour on a sales call? Yeah. Can you do a quarter of an hour on a sales call? Yeah. Can you do an eighth, a 16th? You could do any fraction or any decimal between those. The most number of sales calls that you can make in a day is 24 hours. Number of hours of sales calls, number of hours spent on a sales call is 24 hours. But you could do all the integers in between and all the fractions and decimals in between. So this is an example of a continuous random variable. So again, as we watch this, just be sure to take notes as if you're in class. If you have questions, write them down, and you have to reach out to me to get them answered. We also have tutors. If you'd like to connect with one of our virtual tutors, they're live. It's just like if you would go to the tutoring lab on campus, but we just created a live version of it. Just reach out and we can connect you with them as well. Okay. So let's look at this example. It says determine whether each random variable x is discrete or continuous and explain your reasoning. It says let x represent the number of Fortune 500 companies that lost money the previous year. Okay. What's the least number of Fortune 500 companies that can lose money? It could be 0. What's the next number of companies that can lose money? You could have 1 company lose money. Is it possible to have half a company lose money? No, either the company lose money or it doesn't. So this should be an example of a discrete random variable. Okay. All right, let's look at the next one. So again, we're asked to decide whether the random variable is discrete or continuous. Let x represent the volume of gasoline in a 21-gallon tank. Okay. So what's the least amount of gas that we can have in a 21-gallon tank? We can have 0 gallons. What's the next number of gallons that we can have in the tank? If you're tempted to say 1 gallon, that's fine. Then my next question would be, is it possible to have half a gallon? Yeah. Is it possible to have a quarter of a gallon? Yeah. You see how that can just kind of keep going? So then that's an example of a continuous random variable because there's so many outcomes that you can't even begin to count all the possible outcomes. So this is an example of a continuous random variable. Okay. So for a discrete probability distribution, it lists each so to make a discrete probability distribution, list each possible value the random variable can assume together with its probability, and it has to satisfy the following conditions. The probability of each value of the discrete random variable is between 0 and 1, inclusive. Inclusive just means we include the endpoints. And then the sum of all the probabilities is 1. So the probabilities add up to 1, and each probability is between 0 and 1, and they could also be 0 and 1. Also, I do see that I do have somebody in attendance for this is applied statistics. I am monitoring the live chat via YouTube. So if you do have a question during this live session, you're more than welcome to submit it in the live chat, and I'll respond to the questions that I see there. Okay. Moving along. All right. Constructing a discrete probability distribution. So we're going to let x be a discrete random variable with the possible outcomes. We want to make a frequency distribution for the outcomes, find the sum of the frequencies, find the probability of each possible outcome by dividing its frequency by the sum of the frequencies, check that each probability is between 0 and 1 inclusive, and that all the probabilities add up to 1. Okay. So we have this example, and let's do like this. We are going to add a page. All right. Oh, not there though. All right. Oh, come on. I think we're golden now. Okay. Can I? No, that doesn't behave the way I wanted to. Okay. So let's look at this example on constructing and graphing discrete probability distribution. An industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, where 1 was extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. Okay, we can do this. Let's get a copy. Well, okay, here. Let's introduce some graph paper. I just like I don't know what it's about. Okay, so we're gonna make a table, right? We have our variable x along with the scores. So we have the 1, 2, 3, 4, and 5, right? I'm going to go ahead and include the frequency. So we had 24 ones, 33 twos, 42 threes, 34s, and 21 fives. So if we want to find the probability of each one of these, we need to find the sum of the frequencies. So let's add these up, right? 20 plus 30 is 50, plus 40 is 90, plus 30 is 120, 140, 141, 43, 46, 150. Oh, duh. Yeah, that was in the text. So that's good that they added up to that. So we have our 150 participants. So then let's find the probability of each x, right? So we're going to find the probability of each one. So basically, we're going to do 24 divided by 150. I'm going to introduce, let me see if this works here. My trusty dusty rusty. Just on a new page. Okay, so you guys can't see it. What if I go like this? That doesn't change it either. What if I move it over here? I know one of these works. There it is. Okay. So let me load this thing. I gotta load the calculator. I agree. Choose the file. Browse. Let me move it back over here until I get my file. My calculator. I'll go to browse. Give me just a moment. I'm just trying to load this calculator. No, this isn't right. These are not all my files. There it is. Okay. Let's go here. Calculator. I guess it's that first one. Let's do that first one. See what happens. Is that on it? Okay. Let's do this one. It looks good. Let's reload and refresh. Okay, that looks right. Okay. So we're gonna load our calculator. Let me just reload it and refresh it one more time. All right. So now let's find the probability of each of these outcomes. Yeah. So we had 24 divided by 150. So that has a probability of 16% chance of occurring. 33 divided by 150. My audio's working, right? Yeah. So that's a 22% chance of occurring. 42 divided by 150. 28% chance. 30, what is that? 1/5? Nope. 30 divided by 150. 20%. And then 21 divided by 150 is 14%. Okay. Notice that all of these probabilities are between 0 and 1, and they should add up to 1. Let's just go ahead and add these up really quickly. 10 plus 20 is 30, 50, 70, 80, 84, 92, 94, 100. Yeah, so they add up to 100%. Okay. Okay, so we have each x with each of their probabilities. Then it asks us to construct a probability distribution, then graph the distribution using a histogram. Let's see, how do I want to graph it? So I'm going to shrink this down. Oh, I guess we're done with this. Let's see. So we could actually graph it based on the frequency or the probability. Since we found the probability, I'm going to graph it based on, actually, I'm going to graph it based on the frequency. You know what? I'm going to just glance at the answer to see what formula they put it in. They did it based on the probability. That's exactly what I was about to do. Okay. So since we found the probability, let's just go ahead and graph this based on the probability. So on the x-axis, we'll have the random variable x, and then on the y, we're going to have the probability. All right. Sorry, totally loud in there. All right. Hang on a second. Give me a moment. And we're back. Okay, I'm just gonna go like that. Like that. Cool. Okay. So the x-axis, we have our random variables. So what was those? The score. So here we're gonna have the score. We're just gonna say 1. See, 1, 2, 3, 1, 2, 3, 1, 2, 3. So these are our scores. And then on this one, we're going to have the frequency. We need to go, the highest is like 42, so we need to go to like 50. I'm going to go by tens. 10, 20, 30, 40, 50. So this is going to be 10, 20, 30, 40, 50, 60. That's fine. And then we got 1, 2, 3, 4, 5. Let's shrink this down to about there. 60. These were the scores. These were the frequencies. Oh, sorry. Oh, we sure did just say to do it based on probability. So let's do it based on probability. I don't know why I'm like so intent on doing it based on frequency. So then the probability, it only goes up to about 30%. So we'll say 10%. Nope. Hang on. So say this was like 30%, half of that, 5, 10, 15, 20, 25, 30. So we could say 5%, 10%, 15%, 20%, 25%. Okay. So then to graph these, I'm actually going to use, let's see. So the first one went up to, let's try that again. 16. Okay. 16 is about there, right? Because if that's what, 17 and a half, so something like that. Let's not go halfway. All right. And then I'll fill it in later. So that's the first one. Let's see. The second one went up to 22%. So actually we can just copy and paste. Copy. Let's paste. And this one needs to go up to 22. So that's 20. That's 22.5. So about right there, right? And then number 3 goes up to 28. So that's 27.5. So about right there. And then number 4 goes up to 20. 20 is right there. And then 5 goes up to 14. And I'm going to fill it in with this color. Nope. Let's undo. Let's do like this, like that. And then let's go like this, style. Stroke is fine. Nope, there we go. Let's copy. Oops. All right, and then that one goes here. I'm just being a little bit extra. Paste. Paste. And paste. Okay. So yeah, this is the frequencies based on the probabilities, all right? So then based on this, you can see which one is most likely to occur. Okay, I think this is okay. This looks fine. Okay, so you saw me do it by hand. Let's go paper, get rid of that. All right. So let's compare it to what was in the notes. So we divided the frequency of each score by the total number of individuals in the study. Okay. So I think we got those probabilities, and then this is valid because this is a valid discrete probability because each probability is between 0 and 1 inclusive, and they all add up to 1. So then to construct a histogram, so notice they went up to 30. Now there's a touching, so I probably should have made mine touch, right? I shouldn't have those spaces in there. Let's see if I can, how easy to fix that is. Paper. Let's see what I can do. I want this to go halfway. Yeah, it's a fairly straightforward fix. Nope, undo. And then these need to be expanded. Okay. What else? I think everything else was fine. And you don't really need this next part that I'm doing. I'm gonna just do it anyway though. Matter of fact, let's just copy this guy. I'm just having fun. Copy and paste. Let's do the 30. Let's do the 20. We're gonna get some more lines in there. That's 10. How do I feel about this? I don't know that I like that view. What I can do, let's go style. I wish I can like choose, I want this to be like translucent. Can I do a new color? Ugh. Let's go back. Oh, and it's behind. I'm good. Let me just put it back. I'm gonna put that back, and I'm gonna get rid of these lines. We don't really need them. It's not that serious. I'm gonna just get rid of these guys. Boom, just like that. Okay. But you get the gist of it. I'm just, like I said, I was just having some fun. Give me just a moment. And we're back. Okay. All right. So let's keep moving. So, but yeah, you see the gist. We got it all there. I think it all passive aggressive traits. I think that's the only other thing we needed. Probability, right? Did I put frequency there? You want to label it properly too. But you get the construction. You know, we need the labels. Let me see. These are the probabilities over here. So these are our P of X. These are the probabilities. And then these are, we need a title for the actual table. Passive aggressive traits. Passive aggressive traits. And one other thing. Let's push that down. Boom. Okay, that's fine. Aggressive traits. Let me make sure. Yeah, I think it's fine. Okay. All right. Okay. So verify that the distribution for the 3-day forecast and the number of days of raining is a probability distribution. So if we wanted to verify that this is indeed a probability distribution, each probability needs to be between 0 and 1, and they need to add up to 1. This is 20%, 43%. So these are between 0 and 1, and then let's add them up to see what do they add up to. I'm loading my calculator. Okay. All right. So let's see what these add up to. Let's do 0.216 plus 0.432 plus 0.288 plus 0.064. They should add up to 1, and they do. Okay. So then that's it. So we would say yes. Okay. Determine whether this is a probability distribution, right? So notice that each probability is between 0 and 1. If we add these up, 20 plus 20 is 40, plus 40 is 80, plus 10 is 95, 98, 99, but it looks like it goes over 100. So these add up to more than 100. So each probability is between 0 and 1, but the sum is greater than 100. So this distribution is not a probability distribution. Okay. Let's see. Okay, notice all of these are not between 0 and 1, so this is not a probability distribution. Okay. So let's look at the average. The average of a discrete probability distribution is going to be the sum of each x times its probability. Let's kind of go back really quickly. So when we did this this example, right? This previous example, we had the frequency, right? We had the frequency of each x. So if we were doing average just in a normal sense, how do we find the average? The average, we're going to do what? Add up all our terms, divide by the number of terms, right? So if we wanted to find the average here, we would add 1 up 24 times, plus 2 added up 33 times, and then we would divide everything by 150. So the formula that we just had was each x times its probability. So if we add 1 24 times, that's the same as 1 times 24. And then when we divide by 150, we will get the 24 divided by 150. So we'll have each x times its probability. Hopefully you were able to keep up with that train of thought. If not, it's okay. I was just trying to make a connection between what should be normal or what should be familiar as far as the average and then this new formula that we have. All right. So to find the average of a probability distribution, we're going to take the sum of each x times its probability. Okay. We have the probability distribution for the personality inventory test is given. Find the average score. Okay. I don't really want to see the answer. So basically it's just going to be the sum of each x times its probability. So we're going to say the 1 times the 0.16 plus 2 times the 0.22 plus 3 times the 0.28 plus 4 times the 0.2 plus 5 times the 0.14. And we get this 2.94. All right, so if you say each x times the probability and add those up, you should get this result. That's the average. So the probability distribution for the passive aggressive traits, find the average score, we get this. So recall that a score of 3 represents an individual who exhibits neither passive nor aggressive traits, and the average is slightly less than 3. So the average personality trait is neither extremely passive nor extremely aggressive, but slightly closer to passive. Okay. So then variance. Recall that variance tells us how spread out our data is. The higher the variance, the more spread out the data. Standard deviation tells us how far our data point deviates away from the average, right? So given the average, the standard deviation tells us the distance from the average. So then if we wanted to talk about the variance of a discrete probability distribution, I feel like this is missing something. Let me look at something real quick. Hang on. Okay, maybe not. Variance. Oh, I guess because the probability is already included in there. Because I was looking for the divided by n part, but okay. So we have the variance, which is going to be sigma squared. This is going to be the sum of each x minus the average squared times the probability, and then we add those up. I keep wanting to divide by n, but I guess we don't need that here, because it would get factored in twice because of the probability. So then once we have the variance to find the standard deviation, we just take the square root of that, and that'll give us the standard deviation of a discrete probability distribution. Okay. So in this example, it says the probability distribution for personality inventory test for passive aggressive trait is given. Find the variance and the standard deviation. Let's give this one a go by hand, right? So we want the variance and the standard deviation. I'm going to see, can I do this one by hand? I mean, with no support. I think I can get it. Let me start by getting a copy of this distribution. Okay. Drop that there. I want to add a page here. All right. So we're asked to find the variance and the standard deviation. Okay. Let's do paper. All right. So the variance should be the sum of each x minus its average squared times the probability of each x. And then the standard deviation is going to be the square root of the variance, which is going to be the square root of the sum x minus mu squared times p of x. Square root of all of that. Okay. So let's start off by finding our average. Our mu is going to be the sum of each x times its probability. All right. I think we just found that as what, 2.94, right? So we have our mu. So again, our variance is going to be the sum of each x. So let's do it this way. Let's find this. So we have our x. Let's put it here. We got 1, 2, 3, 4, 5. Let me add a page. And then we have the probability of each x. And we got 16, 22, 28, 16, 22, 28, 20 and 14, 20 and 14. Okay. So we have our mu. Let's go ahead and find each x minus mu, right? So that's going to be what? Negative 1.94, negative 0.94, 0.06, 1.06, and then 2.06. That looks right? Okay. Then let's do each x minus mu. Let's take those and square each one of those. So I'm going to use my calculator for this part. Okay. Let's see. Let's do this negative 1.94. What if we hit square it like this? No, that's no good. Negative 1.94 squared. So let's put the 3.7636, 3.7636, 0.94 squared, 0.8836. Should be 0036. 1.06 squared, 1.1236, 2.06 squared, 4.2436. Okay. So then we want to say each of those results times their corresponding probability. So let's do this 1.94 squared times 0.16. So we're doing each x minus mu squared times the p of x. So then that one, 60, 2176. So I'm going to say 0.94 squared times 0.22. 0. I'm trying not to round it to the end as best I can, because the earlier we start rounding, the more our answer will be skewed. 1943.92. 0.06 squared times 28. 001, 008. 1.06 squared times 0.2. 2247.2. 2.06 squared times 0.14. 594104. Okay, so then we want to add up those results. Okay, if we add those up, let's do, I'll just put it in one go. 1.94 squared times 0.16 plus 0.94 squared times 0.22 plus 0.06 squared times 0.28 plus 1.06 squared times 0.2 plus 2.06 squared times 0.14. Okay. So if we add up those results, we should get the variance to be approximately 1.62. Approximately, and this is our variance. So then our standard deviation should be the square root of the variance. So it should be the square root of that 1.62, and it's going to be approximately. So let's take the square root of that answer, 1.27. 1.27. Let's see, how do we do? Okay. All right, let's see, how do we do? And let's put you away. We don't need you anymore. Okay. All right, we got 162 and 127. Cool. Cool. 1.3. So most of the data values differ from the average by no more than about 1.3. Okay. So the expected value of a discrete random variable is going to be equal to the average of the random variable. Well, we're actually almost done. It's going to be expected value of a discrete random variable is going to be equal to the average of the random variable, right? So we just did the average was the sum of each x times each corresponding probability for a discrete random variable. Okay. Okay. So in this example, it says a raffle, 1,500 at a raffle, 1,500 tickets are sold at $2 each for 4 prizes, 500, 250, 150, and 75. We buy one ticket, find the expected value, and interpret its meaning. So at a raffle, 1,500 tickets are sold. Okay. Find the expected value. So we need each outcome. We need to make a probability distribution, right? So let's go here, paper. Let's get some graph paper. So first, let's identify each x. What are the possible outcomes of our winnings? So we can win what? What are the winnings? We could win $500. We could win $250. I think it was $150. $75. Or we could win $0, right? Plus, we need to factor in what we paid for these tickets. So we're going to say minus the $2 we paid for each one. Okay. So then this first one becomes what? $498 is the net. 248. $248 is the net there. 148 is the net there. $73 is the net there. And negative $2 is the net there. Okay, so that's the x. So then let's calculate the probability of each x. All right, what's the probability? How many winning tickets do we have at the 500 level? Well, there's only one out of a total of 1,500, so that probability is 1 out of 1,500. I think it's the same for the next 3. So there's only one of those, there's only one of these, and there's only one of these. And then what's the probability of getting a losing ticket? So if we have 1,500 minus 4, the remaining there is 1,496 out of 1,500. That has a high probability of occurring, right? What did they ask us to do? Expected value. So we want to find the average, right? So the expected value of x, which is going to be basically the average So that's going to be the sum of each x times the corresponding probabilities. So then that's going to be 498 times 1 out of 1500 plus 248 times 1 out of 1500 plus 148 times 1 out of 1500 plus 73 1500, and then we're going to say, let's say plus, we got what, -2 times 1496 out of 1500. Okay. So let's crunch these numbers and find these results. Okay. And this is going to be equal to, so we got 498. Let me see. Let's do it this way. I'm going to just do a little bit of algebra here. 1 out of 1500. Nope. 1500. I'm going to say times. We got the 498 plus 248 plus 148 plus 73. Then we're going to say plus this -2 times 1496 out of 1500. Okay, and this should tell us the average. So every time we play, we can expect to lose an average of $1.35 for every play. That's the expected outcome. All right, so in the long run, this is what every time we play, we can expect to lose this much. Oh, okay, let's see, how do we do? 135. All right, let's see, how do we do? $1.35, right? So the game, 498, 248, 148, 73, and -$2, $1.35 every time we buy a ticket. Okay. And I think that actually ends what I'd like to talk about for today. Okay. I think that's more than enough. That rhythm is just about right. Okay. So again, just some highlights from things that you need to be aware of. I do intend to load exam 2 shortly. Okay. So be on the lookout for that. It is due this Saturday by 11:59 p.m. I'm available if you have questions. I think I do have a couple of students I'm going to need to reach out to. So there are a few students that are MIA. I'm going to reach out to them. If I can't reach them, we're going to have to be booted. That's just what our attendance policy is. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.